In this video, we will look at Avo Rpt Module. So the Avo Rpt Module is amplitude versus offset rock physics template. Rock physics template was originally designed to be used in the acoustic VPVS domain, where you are cross-plotting your acoustic impedance, VPVS ratio data, and then on top of that you plot modeled trends which can be used to analyze the data. And what we are doing is that we are extending that to the AVO domain to do a similar type of analysis. So we're going to do this for intercept and gradient as an example, and I go ahead and I'm already connected with Petrel. I'm running center and I'm getting here the different seismic data available. So we can then choose the intercept and the gradient data here. And we can go ahead and also choose a model. This module here, the Avo Rpt, is not as responsive as we would like to see, so that is something that we are going to work on. So we have to be a little bit patient when we're working with this module. So we have chosen an intercept, which is plotted here, and the gradient data, which is plotted down here, TVT versus gradient, and we have chosen a model. Now the intercept and gradient is also plotted in this cross plot here, intercept versus gradient. Now we also need to choose either an inline or cross line to work with, and here we can go back to display the. If we go in here and we choose not to display survey 1, but survey 3 here with the intercept. Oops. And if we also go ahead and we display well A with, for example, effective porosity, and bring that to roughly where the well is intersecting, and we zoom in here a little bit. So we can see that we have the well penetrating here. We have a formation around here with high porosity, then lower porosity, and higher porosity again. So this is around 35% porosity up here, then lower porosity, and then higher porosity down here, right? So this information we bring with us, and this is for inline 89. So we go back here and we choose inline 89 here, which brings us to the right inline to work on, and we will probably be able to recognize those features. The whole point with this tool is to do the scaling of the AVO, and right now we can see that intercept and gradient have too large values. It's at least an order of 1,000 too large. But let's go ahead and just take this down a notch. So let's see if we are getting in the right range here. And yeah, the purpose of this tool is to scale the AVO from relative values to absolute values. So we need one more 0 in there. We can see that the intercept, we have gotten more into the ranges that we would expect to find in our absolute AVO dataset. And now the gradient as well is getting closer. It's not super, but it's a starting point. The next thing to do is to zoom in a little bit on this structure where we had the well penetrating. So we use the zoom button and zoom in here. And we recognize again the two formations. So we had the well penetrating around here, and we had one area up here with high porosity. So when we make this selection here, it will update the selection also in the other windows, down here as well as over here. And we had another high porosity, which was probably down below this. So let's take it in this screen here. So maybe something like this. Let's see where that lands. And to the left here you have the legend. So you have a description here of these trend lines. The red here is the hydrocarbon sand, the blue is the brine sand, the pink is the shale hydrocarbon saturated, and the light blue is brine shale saturated. And right now we have chosen a shale volume fraction of 0.2. This can of course be changed if you want to go all the way to the extreme, to 1 in a shale fraction. And then we can see sort of how this model space spans from clean sand to clean shale. Now we have this construction here. Maybe our selection was not completely right. Maybe it was a little bit off, but let's keep it like that for now. Let's also include what we believe to be that intermediate layer. So at the moment we don't have the facility of bringing in the well log in here, so you have to work a little bit with Petrel and this next to each other in the analysis. Okay, and then we can zoom in a little bit on this window here. And what we know is that the porosity for at least this top part, which we're pretty sure that we have targeted correctly, should be around 35. And we see that 0.30 is here, so 30% is here, and 40% is over here. So we're a little bit over predicting the porosity of this. It's hydrocarbon saturated, but what we could do is try to tweak a little bit with the scaling factors here. Okay, that went the wrong way, so let's go back and instead do 0, like 2 here. So we want to stretch the data here a little bit. There we go. Let's try to stretch it a little bit more. Well, that is stretching. Let's have a look at the V shale here. So the V shale, we have maybe like 40, 50% V shale. Let's also look at the water saturation. So I'm looking in this area with this intermediate area right now. I just want to inspect that a little bit, and I think I need to zoom in a little bit closer here. So we see that it is actually also having some saturations in there, like roughly close to 40% water saturation, so around 50-50 or something like that. So that's just something to keep in mind. Going back here, let's look at this. So what we're talking about are these, and if we change now the volume fraction of shale, so what did we say? It was around 50%. We're thinking about these pink lines here, these pink points here. Yeah, and maybe it was even 40%. So let's try to see where the 40% lands. So I'm looking at this model trend here, and what I want to see here a little bit is that at least some of these points are landing in between the hydrocarbon saturated and the brine saturated shale trend lines, and these are now for 40% shale, and some are overlapping, and we saw, if we go back here, we saw that there were some with which are a little bit more red, so closer to, you know, fully hydrocarbon saturated. So and this is of course just where the well is penetrating and we're catching a larger area, so that could make sense. We have this area here, we have in the top here, which has higher porosity, it seems, than down here. We also have maybe some more shaly, maybe more shaly or water saturated points that we have captured. If we look at the two areas there with when it comes to shaliness, they seem to be the same in those. What about the porosity? So the porosity seems to be a little bit higher in this area than in this formation than in this formation. So it makes sense that we have an overlap, but we have a lot of, there is a little shift down to lower porosities. Now maybe these are a little bit too high, and what we haven't played around with here is the caprock properties, which are also important to work with. So we have just used some caprock properties, the default ones, which are pretty good for this data set here, but you have to go in and modify these based on the location that you are working on. So with this setup, I think that I'm going to say that I'm okay. We could make some changes. Let's see what happens if we do 0.2 there, for example. I think that will not be so good. So we see the effect of that. It's stretching the data points outside of the or to the left of this hydrocarbon line, and that's not good. So let's go back to this one, and I think we have a setup. Now what we need to remember here is these two scaling factors. So 1 E-4 for RP data and 3 E-4 for the G data, and that is something that we will use in the next video when we are doing risk with AVO data. But before that, I'm just going to have a quick look here on the Avo Angle Stacks. It follows very much the same principle, but here you choose a near and a far instead of intercept and gradient. You have the scaling factors, you choose your inline cross line, but also for the near and the far here, you need to choose the angle, the representative angle for that angle stack. So typically the near will be low, maybe 5 is a little bit low, maybe it's 8, and then your far, maybe it's 30, maybe it's 35. You will find that in your data set. So you need to put in that as well. And when that is done, you will have some trends plotting in a little bit different direction than what we see here. These are the old trends showing, but you will have some other trends and the data will be plotting. But you follow, in principle, the same procedure, finding the scaling factors.